Hello, hello, hello. If you're watching this, then you missed day 2, our week 9 Foundations of Technology class. Let's go ahead and get started. So first of all, really important, the last day I will take any makeup work for this class is going to be Wednesday the 4th. That is next week. Please, 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 if you owe me anything at all, that is the last time I will be changing grades. Anything after that, I will not be accepting. I'll give you feedback on it, but I'm not changing your grade. That way, I can get all the grading done in time for first quarter grades. All right, so please keep that in mind. Assignment 16, orthographic projections, was due last night, Wednesday. If somebody didn't turn it in, please, please, please make sure you get it to me. Assignment 17 is what we worked on today, and that's what I'll be introducing to you, or at least the tools you'll need in order to be able to do it. Our objectives are given a three-dimensional shape to create orthographic projections of it, and I'm hoping that ultimately next week we're going to be constructing a 3D model based on those orthographic projections. Now there is a form you need to fill out in order to be able to use the requisite software next week, and I will show you that form in just a moment. Alrighty, let's go ahead and take a look at the actual skills you'll need. So this is an example of a shape similar to the one you'll be working with on your assignment. This one's slightly trickier, has a little bit more intricate parts to it, but I'm hoping it won't be too crazy. Let's go ahead and give it a shot. So the first thing you want to do is you want to figure out the dimensions of the top, front, and side. What we're doing is we're creating orthographic projections, meaning views. If you were to look straight down, straight from the front, or straight from the side at this shape, what would you see? It's important that we note exactly where all the edges are in each of those views so that we're not missing anything. And ordinarily, you would prefer to see those rather than have all the labels for measurements inside here, because look how busy that drawing is. It's very, very hard to read. So let's go ahead and try this. To start with, let's go ahead and make a box that represents the size of our top view, the size of our front, and the size of our side view. So maybe let's label them. So I'm going to put my top view always up here at the top. Just makes sense to do it this way. The front view right below it, so I can preserve the length dimension along those two. And the side goes over here so that I can preserve the height. Now, the length of this shape is 10, and the depth, which is the other measurement you'll need if you're looking straight down, is, well, half plus 2 plus half is 3. Now, what I'm going to do for my example is I'm going to double everything just to make it a little bit easier to see. You can make your orthographic projections larger or smaller if you scale them by a factor, as long as you stay consistent. So if you multiply every dimension by 2, that's fine. You can also divide every dimension by 2. What you don't want to do is multiply some and not others, because then you will skew the proportions of your shape. So let's go ahead and do this. I'm doing this again just to make it a little easier to see what I'm doing. So I'm going to make my shape 20 units in length, double of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I'm going to make it 3 units in width. So or 6 on my drawing. 1, 2, 3, 4, 5, 6. That is the rectangle that'll be large enough to contain the top view of my shape. Alrighty, next I'll do the front. The front will have the same length. I do not need to remeasure it. And I'll need the height. The height is 3 plus 1 for this little top cylinder piece. So altogether, the height will be 4 units tall. Let's go ahead and draw that. So if I want it to be 4, I'm going to make this total measurement 8. 1, 2, 3, 4, 5, 6, 7, 8. Now these are a little close, so maybe I'll drag my top view a little higher up so it's not in my way so much, like so. All right, let's do the front. So 1, 2, 3, 4, 5, 6, 7, 8, and it'll be the same length. So it'll be exactly 20 units long, which represents 10 on my drawing. Next, I'll do the side. The side has a depth of that much, which in our case is 6, which represents 3 on the drawing. It'll have a height of 8. Let's go ahead and draw that. So for the side view, I'm going to move this down a little bit. I'm going to draw in 1, 2, 3, 4, 5, 6, and 8 units tall, like so. I'll make that transparent. Okay, these are the rectangles that are large enough and are aligned perfectly to contain our shape. Let's go ahead and draw what we see. If we look straight down, what do we see? Well, a good place to start might be the side edges. Surely we will see this side edge and the one back here as just straight lines. So those will be pretty easy to draw. I'm just going to draw a straight line along this side, and I'll make it a different color just to see it a little better. And I'll draw an edge along this side as well. And let me just line that up a little better. There we go. So those are my two sides. Next up, we want to fill in maybe some edges over here on the side view of our shape, this side. We have a little Y type deal going on, and we know each of these outer horns are half a unit in depth. So to represent that, I'm going to draw them as 1 unit on my shape. Another reason I chose to double everything, to avoid dealing with halves. So that is there. Then notice the length measurement of this side right here is 1. So on my drawing, it'll be 2. And the same thing will happen on the other side since it's symmetrical. And the depth here is 2. So on my drawing, it'll be 4, like so. So that is what I would expect to see on the side over here. Next, we want to go ahead and find out where this edge is, because we would see that from the top. It is 5.5 units from the back. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units over, and I draw a line leading up to it. Now, sometimes the snapping action occurs, and that's really annoying. So what you can do is you can draw a straight line a little bit farther away, and then drag it into place, like so. Just be careful not to adjust it afterwards, or it'll try to snap to that grid again. Okay, and then we know that the depth dimension right here is 1. So there's going to be a gap of 2 units, since we're doubling everything. And then there will be another line. Let me go ahead and just copy this one and drag it down here, like so. And make it a little longer. There. Okay, so we now have these lines drawn. Next, we need to figure out this divot that's going over here. It's 2.5 units this direction in length. So I'm going to draw that in. 1, 2, 3, 4, and it's going to be 5 units on my drawing. It's going to be doubled. And then it is 1 unit deep and 5 units back. All right, we're almost done. We need to figure out where this edge goes, and it is 4 units from the end. 1, 2, 3, 4, like there. And last but not least, we need to figure out this place in the circle. This is the slightly tricky part of doing these. That is, if something is not specified, you have to assume it's in the middle. That is the default assumption that engineers will usually make in these kinds of drawings. So since it's not specified where this goes, this bottom part of the divot, you have to assume it extends out to the middle between these two edges. So it's going to go out 2.5 units on our drawing, then this way and back. and that will be what the divot looks like. To draw the circle, we have to assume it's in the center of this area, or right there. We also know that its diameter, which is a symbol like this, meaning diameter, is 2, meaning its radius is 1, meaning on our drawing, its radius is 2 and its diameter is 4, since everything is doubled. So I'm going to go ahead and draw a circle, and I'm going to draw a circle of diameter 4. I'll make it transparent, and I'll drag it over here to the center of this shape, like so. Man, it's not quite circular. It came out a little bit of an oval. There we go. So I'm going to make that the same color, and we are all set with the top. That is every single line that you need to transfer from here to here. Now to do the front and the side, it's a little bit quicker because now we can use some guidelines from up here to fill the missing pieces. So let's go ahead and do those real quick. There's a line going along the bottom. There is a line rising up exactly 1 unit. So on our drawing, it'll be 2. We go back 2 units, or on our drawing, it'll be 4. 1, 2, 3, 4. Then we need to connect from here all the way up to here. Well, the place where that'll happen is where on this top view, we see a change. So I'm going to draw a guideline going straight down. Now it wants to snap to the grid here, so I'm going to have to move it. The guideline is right here. This is where I should see a change in that elevation. And we know there's a height of 3 back here. So in our drawing, we'll make it 6, where this top flat line goes. So I'll draw that in first. So let's go ahead and put in a line exactly 6 units up. 1, 2, 3, 4, 5, 6. Straight across, like so. And that is the point at which we should start to see a slant. So from here down to here should be a slanted line. Let's go ahead and put that in. So a line connecting these 2 points. And we're almost done here. The last order of business is to add in the profile of this cylinder, which from the side or from the front will look like a box. And we can put in a guideline to help us from the top here, since our cylinder has the same length up here as it does here, then we know that our box should go between these 2 guidelines, like so. And that is the final drawing from the front. Let's go ahead and do the side to finish up. So to do the side, we need to look over here at these measurements. We have a half a unit in, which on our drawing will be 1. We already know that from up here as well. You can look at lines that run up and down on your top sketch and transfer them to be side to side on your side sketch, and that'll be correct. We also have something that goes up 1 unit, which we can see here. We could draw a guideline there if we wanted to. And there's going to be a straight edge running along the top here. And the other little box or horn, however you want to think about it, is over there. Let me draw that a little nicer, like so. Alrighty, so to finish up, we need to do we need to show what's happening up here. Let's go ahead and do that real quick. There's going to be a line straight across there. Remember, we go to the middle when in doubt for the divot, and there's a box up here at the top where the cylinder is. That is roughly the outline that we should see from the side view. If you understand this, then you'll be able to do the assignment, which is posted underneath week 9 and is titled Assignment number 17. Please make sure you do it, and make sure your parents fill out the Tinkercad form so you're able to participate next week. Thank you all for coming, and have a great rest of your day.